Good afternoon, students. Yes, in this class, I am going to explain a very important concept, that is classification of elementary particles. The title of the concept is classification of elementary particles. In nature, the particles are classified into two categories based on their spin. Only spin, particles are classified into two different categories. So, half-odd integral spin particles are called fermions. Integral spin particles are called bosons. Then there is a question arises: what is spin, or what is spin angular moment? So, according to Olympic and Gauss-Smith hypothesis, every particle in this nature possesses its own intrinsic spin named as spin angular momentum, according to Olympic and Gauss-Smith hypothesis. Later, the spin angular momentum experimentally verified by Stern and Gerlach by using a silver atom. So, in which they confirm, Stern and Gerlach confirm, the electronic spin S is equal to 1 by 2. So therefore, according to this experiment, we can say there is no particle with no spin in this nature. So every particle possesses its own spin. So therefore, the particles classification is based on the spin angular momentum S. So either the particles are having half-odd integral spin or integral spin, but the mixed symmetry do not exist. Either the particles have half-odd integral spin. So S is equal to n by 2 h bar. Here h bar is the dimension of the quantum mechanics. Everything can be expressed in h, either h bar or h. Here n is an integer, can take values 1, 2, 3, 5 and so on. So here n is equal to 1, 3, 5. 1 by 2, 3 by 2, 5 by 2 and so on are called fermions. So half-odd integral spin particles are called fermions. The second category, the spin angular momentum of the particles is nh bar. Here n is an integer, can take values 0, 1, 2, 3 and so on. If suppose 0, if n is equal to 0, 0 spin. If n is equal to 1 h bar, 2 h bar, 3 h bar and so on. So these integral spin particles are called bosons. So fermions are half-odd integral particles, bosons are integral spin particles. So based on this spin angular momentum, is purely particles are classified fermions and bosons. Therefore, what are fermions? The next question is, what are fermions and what are bosons? So for example, bosons, let us take bosons. In nature we have half-odd integral spin particles. Number 1, photon. Photon is a 1h cut or 1h bar spin particles. Number 2, graviton. Graviton is also a boson. The spin of the graviton is 2h bar. And also, third one, mesons. Meson is a responsible particle which is available between nucleons inside the nucleus. So the mesons also classified into 3 more subcategories: ions, kaons, and eta meson. So photon, graviton, mesons are the examples for bosons. The title of the topic is classification of elementary particles. You know that matter is made up of electrons, protons, neutrons. So these electrons, protons, neutrons are called material particles. They are called only fundamental particles, but they are not elementary particles. Ultimately, the basic building blocks of everything, even for fundamental particles also, generally quarks. Quarks are fermions. Let us see the classification of fermions. Fermions. So as you know that fermions are half integral particles. Spin of the particles is n by 2 h. So these fermions further classified into baryons and leptons. Fermions are further classified into leptons and baryons. So the leptons are nothing but material particles like electron and its neutrino and its antiparticle positron. So electron and its antiparticle positron and its neutrino and its antineutrino. Neutrino and antineutrino of electron. So the lepton family also mu minus. If antimatter exists, antiparticle also available, mu plus, their neutrino and antineutrino. And also tau minus, if antimatter exists, tau plus, their neutrinos and antineutrinos. So the leptons are classified into three more categories: electrons, muons and tauons, which are experimentally detected, which is discovered by J.Z. Thomson. In some experiments, muon, tauon and cosmic rays, they discovered muon and tauon, neutrino and antineutrino. Where the baryons are again classified into two types: nucleons and sigma hyperons. These are called hyperons. So baryons are classified into nucleons and hyperons. Where nucleons are, that protons and neutrons are collectively called as nucleons. If antimatter exists, antiproton is available. If antimatter exists, antineutron is also available. So proton, neutron are called nucleons. Where the hyperons are again classified into sigma, lambda, omega and castor. These four more particles, hyperons. So if we combine leptons with hyperons, we call it as hadrons. So basically, there are four fundamental interactions are responsible between these particles known as fundamental particle interactions. Number 1, electromagnetic interaction. Number 2, gravitational interaction. Number 3, weak interaction. Number 4, strong interaction. So basically, the gravitational interaction is available between two heavy objects, which does not depends on charge, color, size. So according to electromagnetic theory, which is available between only charged particle, does not available between uncharged particles. So electromagnetic theory, gravitational theory are also weak and strong interactions. So ultimately, this particle physics, strong interaction is responsible between the mostly particles, which is known as a nuclear force. The best example for strong interaction is nuclear force. Nuclear force has some characteristics, very important characteristics, which is spin dependent, charge independent, saturated force, tensor in nature, and strong forces known in nature, which is very strong electromagnetic force, gravitational force, and also weak interactions. So the responsible force between these particles are nothing but nuclear force.